Hello children, we'll be starting the third chapter and the first unit that of water. You can see the syllabus from your book, whatever is written, and everything is very important if you consider the next class, that is class 10. Now formula of water is known to you, which is H2O. It is also called dihydrogen oxide. Two hydrogen and this is the oxide of hydrogen. If you consider the molecular mass, it is 2 into 1 plus 16. 2 hydrogen, 1 for atomic weight of hydrogen plus 16 into 1. 1 means 1 oxygen, and that is 18 atomic mass unit. So this you should remember now, because by this time you might have learned it. Now what is this? This is shown in your books, that's why details will be discussed in the bonding chapter. This is hydrogen. Hydrogen is having 1 electron. This is hydrogen. 2 hydrogens are there. This is also having 1 electron in its valence shell. This you have learnt in the last class. This is oxygen. The electronic configuration of oxygen is 2, 6. 6 electrons are there in the valence shell. Now oxygen requires 2 more electrons to complete its octet, and hydrogen requires 1 electron more to complete its duplet, that is helium structure. So what they will do? They will do the sharing. You can see hydrogen and 1 oxygen electron are shared, and this again sharing. So this region is shown as the sharing part, and these 2 electrons are there, which are called lone pair or non-bonded electrons. All this will be done in detail in chemical bonding chapter. So water is having 2 lone pair of electrons. So you can write this way also. There are 2 ways to write the structure. One is called Lewis structure. Now, and it is a valence shell structure. So these 2 structure you have to learn. One is there in class 9, another is there in class 10 syllabus. And this is ultimately you get water is a polar compound. You will know in periodic table in class 10 again, oxygen having more electron attracting power, because oxygen is hungry for electron, because it requires 2 more electrons towards for completing octet. So oxygen is electronegative. Learn this new term, which is again we discussed in class 10 as well as in chemical bonding. Oxygen is having more electron pulling power than hydrogen. So oxygen pulls the bonded electrons as well as his own electron towards itself. So there is a little negative charge which is shown by delta negative, and little positive charge which is shown by delta positive. So there is a charge difference over here. Now I will show one video. You can see this. How water is formed. Hydrogen you are having 1 electron in each. Oxygen is having these 6 electrons. They share with each other, and it is a triangular structure, you can see. See, this is the lone pair of electron, 2 plus 2, 4. This is lone pair of electron. Then you are having the bonded electron, which is shown by Be. This is the bonded electron, that is shown by Be. Here lone pair is all it is also called non-bonded electron. So come back to the next one. So detail will be again discussed in your bonding chapter, so don't worry about it. Now it is the important natural resource. 70%, more than 70% of earth is occupied by water, and hardly 2.5% of this water makes up the world's supply of fresh water, including the frozen water in polar ice caps as well as the glaciers. Now water exists in three physical states which you know. One is ice, another is solid, and as a gas, or it is the water vapor, and it occurs in both free as well as in the combined state. It is a major constituent of all living beings, most as well as the atmospheric environment. Nearly 70% of our body weight is water. Water has ability to dissolve wide range of substances. So this is very important term. This is called universal solvent. Now, ability of water to form solution is responsible for all life processes occurring in nature and the substance of life on earth. And this is the basic cause because it can dissolve many solute. So this is the basic cause of pollution. If you go to the pollution chapter, which is there the last chapter in your book, you will be finding that water can dissolve different types of gases to make acid, and that will cause the atmospheric pollution. Now this is purified for drinking purpose by removing suspended impurities, by filtration, dissolved impurities by distillation, bacterial impurities by adding calculated amount of chlorine. Now come to the physical properties of water. Pure water, if you go through, it is a clear transparent liquid, generally colorless, odorless and tasteless. Taste of water is due to the dissolved gases and various salts in it, that is impurities. Now what about the boiling point? If you have under normal pressure, which is 760 mm of mercury or 1 atmosphere, pure water boils at 100 degrees Celsius. Boiling point of water varies with pressure. This is very important point. This is very important point for you. Boiling point of liquid is the temperature when vapor pressure of the liquid equals the atmospheric pressure. Next, so the greater the pressure, higher is the boiling point and vice versa. So what we have said, boiling point of water varies with pressure. Greater the pressure, higher is the boiling point and vice versa. And this is the principle of pressure cooker. This is the principle of pressure cooker. What is this? This is the greater the pressure, higher is the boiling point. Now there is a question. In hills, water boils at a temperature less than 100 degrees Celsius. Now what is happening at Mount Everest? Water boils at 70 degrees Celsius. So food is not cooked easily and properly, because food can be cooked only if water boils at 100 degrees Celsius. So if you use pressure cooker, then higher will be the pressure and the boiling point can be reached very easily. So boiling point of water increases with the presence of dissolved impurities. This is also very important note. Boiling point of water increases with the presence of dissolved impurities in it. Next, now come to the freezing point. So remember these two, greater the pressure, higher is the boiling point, and vice versa. Boiling point of water increases with the presence of dissolved impurities in it. Next, freezing point or melting point of ice. Pure water freezes at 0 degrees Celsius under normal pressure, at that is 1 atmosphere. Freezing point of water decreases with increase in pressure. Again you remember this. Freezing point of water decreases with increase in pressure. Freezing point of water decreases with dissolved impurities in it. These two are very important points. Freezing point of water decreases with dissolved impurities in it. Next come to the density. This is again a very important part. At 4 degrees Celsius, water has its maximum density. That is 1 gram per cc or 1000 kg per meter cube. So it has the minimum volume. Now remember this, mass per volume is equal to density. So now if you have more volume, then density will be less. If you have less volume, then density will be more. Density is inversely proportional to the volume for a given mass. Now, if you freeze, water will expand. You will see 92 volumes of water become 100 volumes of ice. So relative density of ice is 0.92 and hence it floats because the specific gravity or density of water is 1. You have seen over here 1 gram per cc. Now come to the anomalous expansion of water. If water is cooled, it contracts first as do other liquid. Now as it reaches below 4 degrees Celsius, it starts expanding. It starts expanding. As it reaches below 4 degrees Celsius, it starts expanding till it reaches 0 degrees Celsius. That is its freezing point. As it reaches below 4 degrees Celsius, it starts expanding. If it starts expanding, so volume will be more and the density will be less. Remember. So till it reaches 0 degrees Celsius, that is freezing point. Then come see this one. What is this showing? Volume of water is at 4 degrees Celsius. It is the lowest. And then if you consider the density at 4 degrees Celsius temperature, it is the highest. Maximum density at 4 degrees Celsius and minimum volume at 4 degrees Celsius. So when we cooled, first contracts its volume. See, if you cool from 10 degrees Celsius temperature, it first contracts its volume. Now at 4 degrees Celsius, it is having the minimum volume. Now below 4 degrees Celsius, if you come from right to left. If you go below 4 degrees Celsius, the volume is increasing. The opposite thing is happening if you cool the water from 10 degrees Celsius to 4 degree. If you will get the maximum density. You see the relation between mass per unit volume. You will be finding. You see the relation between mass per unit volume. You will find mass per unit volume. If you see, you will be finding that volume is less, density is more. Again see the relation. Again see the relation. Mass per unit volume is density. So at 4 degrees Celsius, you are having the minimum volume and maximum density. Next, go to next point. Now, so advantage of this is now marine life can exist in colder regions of the world. Water freezes on the surface, it remains liquid. Water freezes on the surface, it remains liquid below the ice layer. Why? Because ice doesn't allow temperature to go inside, because ice is a bad conductor of heat. Density of water is greater than the density of ice, and ice floats. Now, if you see this, you will be finding now density of water. Now this is density. Density of water is greater than the density of ice once the ice is formed. Here it is that 0 degrees Celsius ice will be formed. So it will again go to this side, downside. So density of water is greater than the density of ice. Hence ice floats on water and it is a bad conductor of heat. We had already shown when the water freezes, it expands. So if volume is more, density is less. So density of water is more than ice. Remember these points very carefully. Now what is happening? Now what is happening to the marine life? This is the ice formed. Here it is water, because ice is a bad conductor of heat and density of ice being less, then it will float. So this ice will not allow outside temperature to go inside. So the marine life can exist very easily in the colder region. Now come to certain definitions like latent heat of fusion of ice. Latent heat of fusion is the amount of heat required to change a substance from solid state to its liquid state at its melting point. So there is no change in temperature when the solid is going to liquid state, and the heat required for this change is called latent heat of fusion. So there is no temperature change, temperature will be constant. So if you want to change ice to water, you will be getting it is happening at 0 degrees Celsius and there is no temperature change. So latent heat of fusion of ice is the amount of heat energy required by the ice to change into water. The specific value is 336 joule per gram or 80 calorie per gram. You have to remember these values. So this amount of heat is released when 1 gram of water solidifies to form 1 gram of ice at 0 degrees Celsius. Due to high specific latent heat of solidification, lakes and rivers do not freeze suddenly. Next is latent heat of vaporization. I am going quickly because you have already done all these things in the previous classes in physics probably. If you boil water, it changes into the gaseous state. The energy required to change water into its vapor at its boiling point without any change in temperature is called latent heat of vaporization of water. And the specific value is 2268 joule per gram or 540 calorie per gram. Body sweats during hot weather. Evaporation of sweat takes heat from the body, giving the cooling effect to the body. Same amount of heat is released when 1 gram of steam condenses to form 1 gram of water at 100 degrees Celsius. So the steam causes more serious burns at than water at 100 degrees Celsius because it contains this much amount of heat, 540 calorie per gram extra. Steam contains this than boiling water. Now, sudden release of latent heat of condensation causes the violence associated with torrential rain. Now, what is specific heat capacity? 1 gram of water when heated through 1 degree Celsius absorbs 4.2 joule or 1 calorie of heat energy. The fixed amount of heat absorbed by 1 gram of water when heated through 1 degree Celsius is called specific heat capacity. Commonly used as coolant in motor car radiators and desert cooler. Water is commonly used as coolant. Due to high specific heat capacity, the presence of large amount of water is able to modify the climate of nearby land areas. If you remember, land breeze and sea breeze, this is the application or reason of high specific heat capacity of water. Now, water is the universal solvent. It dissolves many substances and forms the aqueous solution. When water forms a solution, it is called aqueous solution. It dissolves both solids and liquid. Absolutely pure water thereby is not found in nature. So, water is called a universal solvent. Now, water has a high dielectric constant. This is very important point. Now, what is dielectric constant? Now, dielectric constant is, now detail of dielectric constant will be covered in your physics. Now, dielectric constant is the substances whose molecules contain ionic bond. Now, they will tend to dissociate in water, yielding solutions containing ions. I am giving you a very common example like sodium chloride. Sodium chloride contains ionic bond. For the time being, you just remember this. You will see the details again. I am telling you it in the bonding chapter. So, the large dielectric constant means that substances whose molecules can contain ionic bonds will tend to dissociate in water, yielding solutions containing ions. So, sodium chloride will break in water, giving sodium ion and chlorine ion. So, this occurs because water as a solvent opposes the electrostatic attraction. This is due to the formation of the ions. This electrostatic attraction is the word between the attraction between the ions, or it is also called the ionic attraction between positive and negative ions. Like if you take sodium chloride, so sodium and chloride ions, that would prevent ionic substances from dissolving. Now, the ions of a salt are held together by ionic forces, which is also called Coulomb force. This is not in your syllabus, but this is for your understanding purpose about the dielectric constant. This I have shared with you. We will discuss this water again and electrostatic force, covalent bond, all this in the bonding chapter. So, water reduces the electrostatic force of attraction between positive and negative ions of the dissolving compound or solute. It dissolves inorganic compounds which are electrovalent in nature or ionic in nature. You just learn the terms. Now, substances which seems to be insoluble in water actually dissolve in it in traces amount. Now, if you see glass, this also dissolves in extremely small amount in water. So, when distilled water is kept in silt bottle for longer period of time, it leaves the etchings on the inside surface of the bottle. Now, next is the experiment that show that ordinary tap water contains dissolved solids. This is the experimental setup. Put some tap water on a clean watch glass. This is the watch glass you have taken. Now, this is called water bath. This is also there in your syllabus. They have taken a silica glass tube also, and then a silica watch glass, everything they have taken. Now, here this is called the water bath for the uniform heating. So, clean watch, take some tap water in the clean watch glass, place it over a beaker containing water. Boil the water in the beaker. All the water will be evaporated from the watch glass. Remove it out and see here, see the watch glass. You will be seeing some concentric rings of solid residue. So these are the dissolved solids left. Likewise, you done in evaporation or distillation in your previous classes. These are the concentric rings of solid residue, which is left behind after the evaporation of water. Tap water, river water and well water, they contain dissolved solids, but rain water and distilled water do not contain dissolved solids. Sometimes that's why in absence of distilled water, laboratories can collect the rain water and uses those. So the concentric rings cannot be found in case of rainwater or distilled water because they do not contain any dissolved solid. So if you take rainwater or distilled water in the watch glass and evaporate, you won't find any concentric rings over here. Now come to next point, that importance of dissolved salts in water. There are salts, the dissolved solids are salts, minerals and impurities. What the salts and minerals are important? They are good for growth and development of plants. They add taste to water. They supply the essential minerals needed by our bodies. Now come to the next experiment. Water contains dissolved air. Sorry, it is air. Water contains dissolved air, not water. Air is present in dissolved state in all natural sources of water. Oxygen is more soluble than nitrogen in water. This you remember. Air contains chiefly oxygen and nitrogen, and oxygen is more soluble than nitrogen in water. Composition, if you see that oxygen is more soluble in water compared to nitrogen, composition of the air dissolved in water differs from ordinary air. Now composition of dissolved air in water is 33% of oxygen, whereas ordinary air contains 21%, 66% nitrogen and 1% carbon dioxide. So now they show that the tap water contains dissolved air. This is the experimental setup. Excuse me. Now dissolved gases or dissolved air. You see, this is the round bottom flask filled with tap water and the apparatus is shown as arranged. This is a graduated tube. Here some marking are there. This is the double bend tube. If the graduated tube or burette is filled. You know burette, you have seen when you are in class 6, you have done it. So it is, this burette is kept inverted. There is an inverted burette. Actually this top cock is kept in this side, lower side, but it is the inverted burette. So graduated tube or burette filled. What is graduated tube? Which contains the scale. Burette also contains a scale for measurement. So the graduated tube or burette filled completely with water, inverted over the end of the delivery tube. This is your delivery tube. Taken in a trough of water. This is your trough. This is your trough of water. Heat the water in the flask. What you see, observe. What is the observation? The gas bubbles are seen escaping from the water, collected in the graduated tube. Here it is collected by the downward displacement of water. It was earlier filled. Once the gases are coming, this is downward displacement. Downward displacement of water, it is collected. Water vapor present in the gas condenses on coming in contact with cold water in the tube. The remaining gases come from the air dissolved in water and they escape on heating. Read the volume of the gas collected. How much gas is collected, you just take. Now the volume of the gas or air collected in the graduated tube shows the presence of the dissolved gases in tap water. Now the solubility of a gas is generally present. The solubility of a gas is generally expressed by the volume of that gas dissolved in certain volume of solvent. Now solubility of hydrogen in water is 0.02 volume of hydrogen per unit volume of water, at 0 degrees Celsius. So the gases dissolved in water can be easily expelled by boiling the water. This you can see, this is the experiment. Distilled water and boiled water have no taste. If you drink this water, boiled water, you will be finding no taste. Pleasant taste of drinking water is due to the different salts dissolved in this, as well as dissolved gases like water, air, carbon dioxide, etc. So the taste is due to some dissolved matter like air, carbon dioxide and minerals. Last portion is importance of air dissolved in water. Air dissolved in water is biologically very important, good for the marine life because they use oxygen of the air. Aquatic plants, they use the dissolved carbon dioxide for photosynthesis. This is very known reaction for you. Carbon dioxide dissolved in water reacts with the limestone to form calcium bicarbonate. This is also known here for you. So marine organisms like snail, oysters, etc. extract calcium carbonate from calcium bicarbonate to build their shells. With this, today's session is over. Thank you.